This colossal cosmic entity should logically be absent. Its immense scale suggests it lacked the temporal allowance for formation, yet it unequivocally persists. Situated 5.8 billion light-years from Earth, concealed within a grand assemblage of galaxies, resides a black hole possessing a mass 100 billion times that of our Sun. To grasp the sheer improbability of this, consider that TON 618, formerly recognized as the largest known black hole, accounts for merely 66 billion solar masses. Phoenix A surpasses that celestial titan by 50%. However, according to our current comprehension of black hole accretion, its existence is simply unfeasible. Nevertheless, it exists, vast and inexorable, disregarding the fundamental principles we believed governed existence. In 2010, the South Pole Telescope identified an unusually massive concentration of galaxies in the southern celestial sphere. What astronomers uncovered at its nucleus would cast doubt upon decades of astrophysical theory. The Phoenix cluster housed a central black hole of astonishing magnitude. It also ranks among the most luminous galactic clusters ever observed through X-ray emissions, radiating intensely as superheated gas inundates its core. In astronomical terms, it gleams like a beacon, vividly illustrating the extreme nature of its surroundings. Initial estimations indicated a mass approaching 100 billion solar masses, approximately 24,000 times the weight of the supermassive black hole at the heart of our own galaxy. If our Sun were reduced to the size of a marble, Phoenix A would rival Mount Everest in scale.
Yet its sheer size is not the primary quandary. The true challenge lies in its age. The universe itself is 13.8 billion years old. Black holes augment their mass by devouring surrounding matter, but this process has an inherent velocity ceiling. As matter spirals inward, it escalates in temperature. This generates vast quantities of energy. That released energy repels inflowing material, a phenomenon physicists term the Eddington limit. Even if Phoenix A originated as a seed of 1 million solar masses at the dawn of cosmic time, and continuously accreted at the maximum permissible rate, its mass today should not exceed 10 billion solar masses. Phoenix A is 10 times heavier than physics permits. It has transgressed the cosmic speed limit. One plausible explanation resides within the cosmic dark ages.
It is conceivable that Phoenix A did not originate from stellar remnants, but rather as a direct collapse black hole, where immense primordial gas clouds spontaneously imploded, forming million solar mass entities from the outset. However, a third, more disquieting possibility exists. What if Phoenix A found a mechanism to surmount the Eddington limit independently? Recent observations suggest that certain black holes concurrently exceed this threshold. If Phoenix A accreted in this manner for billions of years, its improbable mass might finally be explicable. This is where Phoenix A becomes truly perplexing. Its host galaxy cluster is currently generating close to 1,000 new stars annually. In contrast, the Milky Way produces approximately 1 new star per year. Such prodigious star formation should be utterly precluded by Phoenix A's presence. Supermassive black holes typically superheat surrounding gas, thereby inhibiting stellar genesis. Yet within the Phoenix cluster, the gas has cooled dramatically, precipitating an unprecedented surge in star formation. The most massive black hole ever observed appears to have relinquished its control over its environment. It is akin to discovering a conflagration that has inexplicably ceased burning, permitting a forest to flourish in its wake. Phoenix A compels astronomers to reevaluate the evolutionary trajectory of the early universe. Black holes of this magnitude would have exerted influence over galaxy formation across vast cosmic expanses. They would have dictated the loci of star formation and the distribution of matter on universal scales. Nevertheless, current cosmological simulations are incapable of replicating such entities so early in cosmic history. Phoenix A is located 5.8 billion light-years distant. Its mass can only be inferred indirectly, leaving room for some degree of uncertainty. However, even conservative estimations position it among the most substantial objects ever cataloged. Phoenix A represents the outermost boundary of what is conceivable within our universe. It is a gravitational behemoth that, by our present understanding of physics, ought not to exist. Whether its mass precisely equals 100 billion solar masses or falls somewhat short, its mere presence fundamentally alters the established parameters. It testifies that the early universe was considerably more dynamic, efficient, and extreme than we had previously envisioned. Somewhere within the boundless depths of the cosmos, this celestial titan continues its ageless ballet with hundreds of galaxies, serving as a potent reminder that the universe still harbors enigmas capable of revolutionizing all our current knowledge.